hydrogen gas is H2, never just H. So often we speak about hydrogen, and you must just know that that means H2. Whenever hydrogen is referred to as a gas, you must just know that it will be H2, because H does not exist stably on its own. It will always bond with something else. If that something else is hydrogen, then it forms H2. So the molar mass of hydrogen is 2 grams per mole. How many moles of hydrogen gas occupy 50 decimeters cubed at STP? STP is standard temperature and pressure, and remember that 1 mole of any gas occupies a volume of 22,4 decimeters cubed, 22,4 liters at STP. So try to answer this question yourself before you resume the video. How many moles of hydrogen gas occupy 50 decimeter cubed at STP? So our conversion factor refers to at STP, decimeters cubed, to cancel that unit away, and mole of hydrogen gas. 1 mole of hydrogen gas has a volume of 22,4 decimeters cubed if it's at STP. 50 divided by 22.4 is equal to 2,23 mole of hydrogen gas. It didn't have to be hydrogen gas, any gas. At STP, if you have 2,23 moles of it, it will have a volume of 50 decimeters cubed. How many molecules of hydrogen gas occupy 29 decimeters cubed at STP? First, try it yourself. So it's not how many moles, it's how many hydrogen gas molecules. Be careful, although this starts with mole, it doesn't mean mole. Molecule and mole are very different. It's asking how many of these HH molecules take up this volume at STP. How many hydrogen gas molecules occupy 29 decimeters cubed at STP? I'm going to do it in 2 steps. If you can do it in 1, that's very good. We know that 1 mole of hydrogen gas, or any gas, occupies a volume of 22,4 decimeters cubed at STP. So that gets rid of decimeters cubed, but it introduces a unit, mole H2, which we didn't want. Mole H2 is not the same as H2. So we need another conversion factor, and this one must have mole of H2 at the bottom to get rid of this unwanted unit. And it must have H2 at the top to introduce the unit we actually want. And we know that 1 mole of H2 is 6,02 times 10 to the power 23 H2 molecules. Notice you could have combined these 2 steps by saying 22,4 decimeters cubed is a mole, and a mole is 6,02 times 10 to the power 23 hydrogen molecules. So if you can see that in 1 step, then you can save yourself some trouble. If you can't, do it in 2 steps. 29 divided by 22.4 multiplied by 6.02 exp 23 is equal to 7,793, which makes it round off to 7,79 times 10 to the power 23 hydrogen molecules. How many hydrogen atoms occupy 90 decimeters cubed at STP? Be careful. How many hydrogen atoms, not H2 molecules? Try it yourself first. How many H atoms occupy 90 decimeters cubed at STP? I'm going to do this in quite a few steps. See if you can do it in a single step, but it doesn't matter. Do it in as many steps as you need to get it right. So we know that 1 mole of any gas occupies a volume of 22,4 decimeters cubed. But now we can't ever just write 1 mole or however many mole. You always have to say mole of what. Don't fall into the trap of being lazy and just writing a mole like that. It'll get you into big trouble. A mole of what? 1 mole of a gas occupies 22,4 decimeters cubed. And hydrogen is in the gas form as H2, not H. So 1 mole of H2 has a volume of 22,4 decimeter cubed. So notice we can cancel decimeter cubed, that's fine. But we end with mole H2, and that is not what we were asked. We were asked H, not mole H, and not mole H2, H. So we need at least one other conversion factor, but I think I'm going to use more. Let's just continue thinking it through. We know that 1 mole of H2 contains inside it 2 moles of H. Here's 1 molecule of H2. Now imagine a whole mole, which is 6,02 times 10 to the power 23 of these. So here's 1 mole of H2. Now we imagine we split that so that that H goes there and that H goes there. And we do that for all 6,02 times 10 to the power 23 of these H2 molecules. Every one of those molecules we split up and we put one of the H's in this pile and the other of the H's in this pile. And when we've done that, we will have 2 piles, each with 6,02 times 10 to the power 23 H's in. In other words, we will have 2 moles of H. 1 mole of H2 and 2 moles of H are the same thing. Now equivalent values. So that cancels away the unit mole H2, but it introduces a unit mole H, which isn't yet what we are asked about. So we need another conversion factor, mole H at the bottom, to cancel away that. And now at last we introduce the unit we actually need, which is H. And we know that 1 mole of H atoms is 6,02 times 10 to the power 23 H atoms. So we could have combined this all in one step, saying 22,4 decimeter cubed is the volume of 1 mole of H2, and there are 2 moles of H2, each with 6,02 times 10 to the power 23 H atoms. So if you can see that, then you could just do it in a single step. But if you need to go step by step in your thinking, then rather do these 3 steps I've shown here. If you do this calculation on your calculator, you find the answer 4,837, which you round off to 4, times 10 to the power 24 H atoms. This many H atoms would occupy 90 decimeters cubed at STP.